Hello and welcome everyone. Today's question is rat in a maze. It is a classic backtracking question where we have to tell all the paths starting from 0 0 vertex to reach n minus 1 and n minus 1 vertex, which is a ending vertex. So let's build the approach. So there are many variety of this question. One is we have to tell whether it is possible to reach the ending vertex. So we have to return true or false. And another variety is we have to return integer. So how many paths are possible to reach starting to destination vertex? So in this case, the answer is 2. And another one is we have to return the path itself. So we have to return string of list of strings. So this is that variety where we have to tell the paths. So as you can see, we have two paths. First we will go down, then we go down, then right, down, right, right. This is one path, and another one is down, right, down, down, right, right. So this is another path. So there is one another variety where we have to start from the given starting point and have to reach the given destination. So here we have to reach 0 0 0 and we have to reach n minus 1 and n minus 1. This is not always the case. Sometimes the path, the starting and destination vertex is provided by the question. So suppose I and j, and we have to reach ending I and ending j. So you can try these varieties also. So let's focus on this question only. So we have to reach this path. We have to start from 0 0 vertex. So we will build a function because backtracking question will usually solve via recursion, and for recursion we have to build a separated function. So we are passing I and j. Initially I and j position is 0 0 and we have to pass our array itself and a path. Initially path is empty. This is a empty string. So we can write this path. This is a string and initially it is empty and ij value is 0 0. So we can only move on zeros and we can assume we can only run in one cell, and we can assume zero cell is a stone in the matrix, and we have four directions: up, down, left, right, and we cannot visit a cell again. So we can write it like this: if I and j inside the matrix, so I, if I is smaller than 0 or j is smaller than 0, or I is greater than equal to n, or j is greater than equal to n, if any of this is possible, means we are outside the matrix. So we will directly return. That's it. But we have one another base case, which is we are on a stone. So the cell number is 0. I, j is 0. If this is the case, we will directly return. Initially, we will know that we are at a valid index. So we are at valid index. So we have four directions on ij. So we can move up, up, down, left, right. So we can move in any manner. This is not required that you first have to move up, then you have to move down. So we can move in any manner. So I am moving first down, I plus 1, j array, and as we are moving down, so we have to add d into our path. This is down, I plus 1, and we can move up, I minus 1, j stays same, and we will add up into our path. This is up, means I minus 1. We can move left, so I stays same, j becomes minus 1, and we will add j minus 1, means we are moving left. So I have to add L to our path, and we can move, I stays same, we can move right. So j plus 1 and add your R into your path. So this is right. So let's start, let's try run this. First we are at 0 0 index, so we can move down. So we have moved down, then we can move down. Okay, then we will move down. So this is our base case. This is a zeroth cell, so this will return. So this will return. So now we will move up, but as you can see, this cell is already visited. So either we can maintain a separate array, or we can modify our inbuilt array, predefined array. So as we know that we are at this cell only if the cell number is 1. So we will make our cell number to 0. So we cannot move on this particular cell again. So we will move 0 0. So we are at this index, and our up cell is 0. Up cell is 0, so we can move this direction, this direction. So this cell is 0, this cell is 0, so move this direction 0, move this direction 0, move this direction 0. So we know the path, and this is our base case. If our I is equal to n minus 1 and our j is equal to n minus 1, we have reached our destination. So we have a global answer. This is our list. So add your path, answer dot add path. So we will add our path into our answer, and we will return from this. We will return from this. So we have a path here, but this is also possible that uh, this ij, this ij is common to one another path. As you can see, we can move. Let me change color. We can move this direction, then down, then this direction, then this direction, then this direction, this direction, then this direction. So while moving backwards, we have to do undo our operation. We made 0, so we have to make now 1, because its initial value is 1 itself, and we have changed it to 0. After traversing all the paths, we have to undo our operation. This is called backtracking. This one single line is called backtracking, and we have successfully solved this question. This will return us correct output. So let's code this. First we have a global answer. This is our list and our n, and we have a function. This is a recursion function. I am passing ij, initial position, and our matrix itself, and our path. Initially path is empty, and we have to return our answer, which is all the paths. This is our function, solve function ij. So first write your base case. If this is not a valid index, this is whether it is outside the boundary or this is a stone, so we cannot move, so directly return from this. As this is our destination, so we will add our path. This is s means this is our path. You can change the variable name. So I am adding my path to our answer variable. Just one thing to note here, I'm creating a new string while adding our path. So this is important, else this will not add your path into your answer. Then return from this, we don't need to go further. And also we have 4 directions. Before this, we have to make sure that we cannot visit this cell again. So mark your cell as 0 and move up, down, left, right. You can write this in any manner. This is not a sequential that you have to first write up, down, left, right. You can first go to right, then left. It's totally depend on you. Then you have to undo your operation, which is backtracking. That's it. Let's submit this code. And we have successfully solved this question. If you still have any doubt regarding the backtracking, you can ask in the comment section. And thank you all for watching this video.